I'm Nishaanth. I'm going to be presenting one of the researches which me and my colleague did as part of an assessment we did for a client, and it's about one of the technologies which we encountered, which is RBI, or remote browser isolation. And yeah, and I'm working as a security consultant with MDSec, and I've been doing pen testing for the last 7-8 years now, and majorly focus on Windows, AD, network, infrastructure, and so on. And yeah, so why are we talking about RBI, and what is RBI about? So like I said, this was part of a security assessment which we did for a client, and the main goals for this assessment was the client wanted to understand if in an environment where there is RBI, which they had, so they wanted to understand if it was possible to deliver malware, or deliver payloads that gets executed, and how that would get detected, or if it would get detected, and so on. So what's RBI? RBI is basically a technology remote browser isolation, and RBI follows this thing called zero trust security model. And basically it's like, it assumes that the user along with the user's workstation is compromised. For example, the user's laptop or the PC that's being used, zero trust security model says that it's assumed that it's compromised and take actions based on the fact that it's already compromised. And how does it work? Does it even work? In short, RBI, or remote browser isolation, is just a browser on a cloud. But if we want to discuss about it in like more detail, RBI uses different techniques. Different vendors use different technique, but according to the specification, there are like at least three ways in which browsers can perform RBI, browser isolation. The first one is basically pixel pushing, which is basically a interactive image or a video sent from the local browser to the remote browser. The second one is DOM, or document object model reconstruction. It's basically when the user visits a website and the response of the website gets rewritten by the browser and it gets redirected. And the third one was using vector rendering, or NVR, and it uses this language or tech called Skia, which is by far the secure and fastest way of isolating content from a local browser. So imagine this is a normal scenario where typically a user is trying to access Google or access any website. What happens is, from the endpoint there is a browser, and when they go to the browser search bar and say search google.com, they go directly to google.com. So the client browser makes a request, does all the DNS, and goes to google.com, and the Google's homepage or the web search page gets displayed. And what's the problem here is that since the client or the browsers directly execute the JavaScript or download files from google.com, I'm just saying google.com as an example. It could be any website, any malicious website serving malicious documents, and so on. What's the problem here is that the websites in this scenario where there is no browser isolation, the user is prone to get infected by malware or web application style attacks, and so on. That's the problem browser isolation is trying to solve. And how does RBI or browser isolation work? In like an overview is the computer or the endpoint would have a local binary or a service installed that will make sure all the requests which are sent by the browser are passed through the RBI. So basically what would happen in this scenario is that specific agent or the service that's installed on the system would redirect or route all the traffic that is generated from the browser, and that would get sent to a remote browser which is there on, say, cloud, and all the actions would get executed there, or the JavaScript would get executed there, the file downloads would get downloaded there in the remote browser instead of the local browser. And once that's done, the RBI agent or the backend would determine if it is a legitimate or a malicious website, if it is a legitimate or a malicious download, and allow or deny it based on the intent of the web activity. And yeah, like I said, all the RBI vendors, they don't follow the same approach towards browser isolation. They have different ways of doing it, and with different ways of doing it, there are like different configurations which you can enable from the backend, and that's what we are going to talk about. And what threats in general do RBI prevent? It's downloads, like preventing malicious downloads in an enterprise, or malvertising, where malware is being distributed through ad networks, and redirection style attacks, where you get sent a phishing mail of a legitimate looking website, but it is actually a malware or a malicious website. And also cross-site scripting, where you could steal a session token using by exploiting the XSS attack on a web application. So these are some of the attacks, or these are some of the scenarios that browser isolation is trying to prevent. Yeah, now that we have talked enough about what browser isolation does, like, we are going to talk about some of the bypasses which we found, which was configured in the environment. So this screenshot, we can see that I'm trying to access lastpass.com, and below in the network developer tools tab, we can see that there is a request that's made to lastpass.com, which is a 200 on the first request, and rest whatever is hidden is basically the request that was sent to the RBI browser. And again, if we see there is a request to lastpass.com after where the obfuscation ends, and again the data is sent to the RBI's browser. So this is a normal scenario in which I try to access lastpass.com. My browser does not request or send a GET request to lastpass.com directly, but it sends through the RBI browser. It tells that, okay, this user wants to access lastpass.com, and these are the cookies, these are the headers, this is what they want to do, this is what they want to download, and that would get executed in the remote browser and come back to you if it is legitimate. Yeah, so while we were checking the source code or the JavaScript for the remote browser website, which gets redirected, we noticed a file, which service worker file, which had like loads and loads of user agents hard coded, and we just thought, like, what's the reasoning behind user agents being hard coded in the RBI browser's website? Could it be the reason that only these user agents are sent through RBI? And it was the case, actually. Like, so if we send a request that has a user agent that's not part of the service worker JavaScript, which is there in the RBI website's JavaScript, what happens is that specific request goes directly to the web server instead of going through the RBI isolation proxy. And what about browser extensions? To the browser extensions, we know that all of the browsers traffic go through the isolation proxy, but what about extensions? Extensions didn't go through the RBI as well, so this way it would be easy for an adversary to smuggle in or deliver like malicious payload by using an extension, since all the traffic is not monitored or not routed through the RBI platform. And Tor browser, like we thought, Tor browser did not respect the proxy or respect the isolation proxy that was in place. So whatever request that was sent using a Tor browser or even Brave's mode of VPN, it didn't go through the isolation proxy, but it directly went to the website. And also we were just wondering what happens when a user who has an RBI product installed, what happens when he visits a website? Does the RBI product in itself add any additional headers, additional cookies, or user identifiable information that can be used for fingerprinting? And it did. Like what was happening was literally to every website that's being accessed by a user that has RBI product installed, the original IP information, the RBI specific tenant information, where is his server located in, the tenant number, basically that's the organization number, and so on. All of these were like sent to any website the user visits. And yeah, like the next thing which we're going to look into is how do you bypass download protections. So in a normal scenario, what was happening is like the link which is there on the second point, the metasploit.com, that's the Metasploit's installer file. And in the client's environment, when we tried to visit this specific link, what happened was we got blocked. We got blocked and said there was a message that said that this binary or this download has malware. You can't download it. So to bypass that, we figured out that instead of downloading the malicious executable directly from, say, Metasploit's website, what happens if we download it locally, host it in our server, and redirect the download to download the Metasploit or malicious software from our server instead of Metasploit server. And in the link on point 4, we can see that we are still downloading Metasploit's executable, but the way we are doing it is using our server as a proxy, using the server we control as a proxy, and that server is going to make a call to Metasploit server to get the executable and download it that way. And this evaded the protection that was enforced by the RBI. And also with the documents that were being opened or downloaded, what was happening was, if I say try to download a document and download and open a document that's from the browser, it did not get downloaded to my local browser, but it got embedded in the RBI browser's website, and the document got displayed there. So this way, there is no way to, deliver malware, deliver a malicious document. But like the more we tested, we found out only certain extensions were being supported by the browser's backend. So if we send a document file that was getting inspected, but we send docm or other extensions, the RBI browser just lets it through, and that gets downloaded directly to your local machine. Yeah, this is the code which Adam wrote to replicate the same scenario which we saw on how we were able to bypass the download protection to download a malicious executable. All it does is we run this specific script in our server, and this downloads Metasploit or whatever binary we want, and serves that specific malicious binary using the server as a proxy. And yeah, like initially, like this specific website ExploitDB was blocked, but since we are proxying it using our web server, we were able to evade the protection and still get to the ExploitDB's website. And also other ways of bypassing which we found was, if a download was being served with a anchor HTML tag or iframe HTML tag, that wasn't getting inspected properly. So any website that embeds malware in an iframe tag or uses a tag to deliver a download, that gets unnoticed by the product as well. And yeah, these two code snippets are like examples of how we were able to use this specific JavaScript in our websites to embed malware and download it without the protection protection getting kicked on the client side. So the first screenshot, which we are just using a tag, href tag, and the second screenshot we are using iframe. And instead of directly downloading the malware from the website, we iframe the malware, and the malware gets downloaded from the iframe and it gets executed or downloaded. And also one another interesting bypass which we found was if a website was hosted on standard ports like 80.443, 8080, 8443 and so on, if that is serving a malicious executable, we were obviously getting blocked by the vendor saying this is a malicious executable. But the same malware, if it was served on a non-standard port like 1337 or 2222, that was not getting inspected by the product and the bypass gets through. And also in recent Black Hat, there's really a good talk on how to bypass secure web gateways by SquareX. I've attached the talks link in my references. Highly recommend checking that out. And also, the next one, we're going to look on how an attacker would be still able to attack a user by XSS. Since the vendor is blocking XSS attacks, what happens in this scenario is, say we have a web application and there is an XSS and someone is trying to exploit the XSS by sending a mail or sending a link to click. Even though the web application has an XSS, the RBI understands that there is an XSS, and someone is trying to embed arbitrary script into the web application, and it detects that and blocks it. So how do we bypass that? When in terms of XSS, instead of just using the script tag for popping up your alert box or popping up your XSS payload, if you just give script alert document.cookie/script, that gets blocked. But if we embed that specific script alert inside other tags like div or frame or svg, like how it's shown in the screenshot, there is a svg tag and there is script XSS payload basically inside that. So this way, since we are embedding our XSS payload inside a SVG payload, that gets bypassed as well. And additionally SVG files were not being monitored properly, were not getting inspected properly. So, and also there is an interesting way in which using an SVG file, you can execute JavaScript. So we just wrote a simple POC of an SVG file, which would eventually execute JavaScript, and that gets through the solution as well. And the last bypass regarding the XSS is using JSONP, which JSONP is basically a technology that was used, that's still being used to allow cross web communications. Basically it's like XML HTTP request, but with lesser restrictions. So we found out that the vendor that we are testing was supporting JSONP endpoints. So we just crafted a XSS payload. So we had the option to write a web application which would eventually support JSONP, or just use an existing web application where there is a JSONP support. So, and Google, the main web search page has a JSONP support by default, and we just used that Google search queries URL to smuggle our XSS payload into the environment. So basically this script, which on point 4, the code which is there is what we embed in the malicious website. And what would eventually happen is this would make a call to Google using JSONP, and that would eventually have a base 64 encoded data of the XSS payload we want to execute, and that gets executed without the solution noticing it. And yeah, like the next thing which we are going to see is how do we go about attacking the agent binary itself. Like during the start of the talk, we discussed that how does the workstation route all the traffic, browser traffic through the isolation product. It installs a binary in your local system, and that binary starts a service. And yeah, that service is always enabled. So like initially we thought, yeah, like what if we query the service, see what permissions the service has, but unfortunately only administrators or system level users were able to start and stop and do basically all the critical operations with the agent. And there were no like service level misconfigurations where you could sideload a binary, or there is a the different type of misconfiguration. Like nothing like that was present, right? But if we looked into the Windows tray, like that specific agent had a icon, basically icon, and when we clicked on that, there was an option called disable. But it that disable, like initially when we thought, when we saw that, was like it wouldn't disable the protection altogether. It will be too simple, like as a low privileged user. So we tried clicking on disable. It did disable the RBI protection which is installed, but automatically what happens in the background is the service gets restarted again, respawns, and all the traffic goes through the isolation product as intended. But what if we click on the disable like multiple times and spam it? It got disabled, which was like really surprising. And when we did mention it to the client during the remediation, they were like really surprised with this scenario as well. And the most interesting part was a low privileged user. The most interesting part is you don't need to be an administrator to click on to basically disable from the system tray. And what happened was, if there are like 5 different users logged into the server or the workstation, and all of the traffic is going through isolation proxy, even if a low privileged user disables it, the solution gets disabled for all the users, even administrators. And insecure cloud segregation, and one of the interesting test cases which we want to focus later on during the project was, we knew that this specific product was was deployed on GCP. So we were assuming it's a tenant subscription, like each client would get a different subscription. So there will be like VPC rules, network filtering rules in place to prevent tenant A from accessing tenant B's data, right? But yeah, that was the assumption. But in the end, what happened was, it was possible for tenant A to access tenant B's data, documents, cookies, and so on, just because all of the resources or all of the products were installed in the same tenant, and they didn't have any proper firewall rules, no VPC segregation in place, and literally everything was in the same place. That allowed one tenant to access different tenants' data, which should not be possible in enterprise deployments. And yeah, like future research and conclusion, I think it's still a very fascinating and new technology. And I think, at least from my perspective, future research in this area would involve more testing on this service binary, so the agent in itself, test more for privilege escalation flaws and service level flaws in all the possible agents. And also, like basically the the whole crux of RBI. They're trying to solve a really tough problem, because since the user has access to the client-side code, he can modify client-side data. He has access to the browser in itself. He could tamper the browser and so on. It's really a hard problem to solve, but maybe in the future this solution becomes more robust. And also, yeah, like each environment would have different protections because of different configurations or different policies enforced by administrators. So yeah, there should be a uniform documentation on saying, yeah, if you disable this, it's bad, and so on. That's pretty much it. That was my talk, and I want to thank Rio. Yeah. I want to thank Rio and Paulina, and also the organizers of B-Sides for conducting this conference. This is my second conference, second B-Sides Tirana. Hopefully I come for the next conference as well. And if you have any questions, please feel free to ask me now.